If you zoom in on any audio file's waveform, you'll notice that it really is a wave. What you're seeing is the digital representation of audio energy that will later be turned into electric current to drive speakers. The speakers represent something similar to digital waves in the air. Your ear picks up these air waves and is able to send a message to your brain, which in turn interprets the wave as sound. There is a distance between the peaks and valleys of each wave, and this may be measured as so many peaks or valleys per second, known as hertz. A frequency of around 20 Hz will sound like a very low hum, and a frequency of about 20,000 Hz will sound like a dog whistle. Musical instruments produce sound waves that you can capture with your computer, either with a mic or by plugging directly in. The principle is to capture the waves and store them as data. The wave produced by a musical instrument is not a simple series of crests and waves. There are waves within waves, known as harmonics, and these inner waves give instruments their particular tonal characteristics. An equaliser, or EQ for short, is used to amplify or attenuate different frequencies. It's as simple as that. However, an equaliser may get very specialised in the way it carries out this task. For instance, some equalisers, like a graphic equaliser, are simple and obvious in their operation. There is a slider for each labelled band of frequency, which may move up and down into a positive, negative or neutral central position. The equalisers that we use most often in home recording are known as parametric equalisers. To be called a full parametric equaliser, the device needs to possess a frequency selection control, a gain control for that frequency, and a bandwidth shaping control or Q parameter. I'm using Reaper for this example, and I'll insert a parametric equaliser into a soloed acoustic guitar track in order to demonstrate some of the uses of a parametric equaliser. You can see that this EQ has the three controls described earlier. Here's the frequency selection control, the gain control and the bandwidth control. This particular EQ is set up as a 4-band equaliser. In other words, there is one set of controls for each band. In this state, the EQ would be said to be flat, as it's not affecting the guitar at all. The 4 bands are represented by the dots with numbers in them, one for each band. The active band is red. We may add or remove bands until the EQ is set up to fulfill our task, but for now, the default 4 bands will be fine. As you've probably realised, the screen for a graphic equaliser plugin such as this is a graph. The frequency is displayed left to right and the amplitude or gain displayed bottom to top. The bottom left represents the lowest frequency and the largest attenuation possible. Seeing as it's already in a good spot, I'll select band number 3 and move it around. Because the guitar is playing music in a certain key with certain chords, it is producing certain frequencies, and it's these frequencies that the equaliser affects. Note that the frequencies outside of the curve that was made by moving the dot are not affected. That is the reason for having more than one band. One curve is usually not enough unless a minor change in one particular frequency area is required. To find some frequencies that you would like to remove, you simply narrow the bandwidth of a band, increase its gain a fair bit, and then sweep through the problem area. The problem will be highlighted, allowing you to reverse the gain control at that spot and remove the troubled frequencies. Watch and listen to this example. By doing that, I remove some boxiness from the guitar. Another good use of the parametric equaliser is for eliminating all but the useful frequencies of an instrument. You would do this in case some car noise or other rumbling had made it into the recording, something that happens a lot when you're working from home. Select the lowest band and set its type to high pass. This means that the high frequencies will be allowed to pass if they are above where the frequency cutoff point is set to. EQ is mostly used to fix problems with the initial recording, or to help multiple instruments to fit into a mix. By cutting the clashing frequencies of one of the instruments doing the clashing, the mix will be clearer and fuller sounding and without any instruments being hidden. EQ can be used as an effect, for instance, boosting only a narrow band of mid-frequencies and cutting everything else, known as a bandpass. You'll simulate the sound of a telephone. As with all creative pursuits, there are no rules, only guidelines to the use of the gear, so play around and see what you come up with. In the next video I'll explore dynamics control with compressors, gates and expanders. Thanks for watching.